We start now, of course, the new course, as you know, today. So this will be, I haven't given you the full content of the course because I don't want to start like a introduction and content. I want to start with the main story and then we'll come back to this one. And I want to start with some fundamentals and some concepts for the tall buildings. So this part one will be 3 lectures. So lecture 1 is going to be about the tall buildings themselves. I want to spend some time on not on the technology, technical engineering stuff, but the building itself, because we need to now, we move to a different level now. We're not talking about how to do some small calculation. We are talking about the importance of these tall buildings, why we have this course and how broad the course is. That's what we will talk today. Okay, so let's start with the role of structural engineers. And I already started my previous lecture also with the same few slides, but I want to go back because now you will understand more why we present those slides, because you have already gone through one full semester with 4 courses. So now we can look back at the role of structural engineers one more time. You remember I showed this slide, I show it every time, that the physical infrastructure is the backbone of economy and society. That means whatever is built by human beings is what the economy and society relies on. Progress is about building something. And that building something is our responsibility, as you know very well. So engineers, either mechanical, electrical, whichever engineers, they're the one who build things. Electrical engineers will do that, mechanical engineers, automotive engineers. Every engineer is building something for the society to function. And without them, and we are building for other engineers also. So if the electrical engineers like Tesla wants to make a car, they need a building, they need a factory. They can't build the cars in the open desert. So they need structural engineers or engineers to build that. So this one is very important. We must not forget our role and our importance. And structural engineers often forget that how important their work is. And I showed that we do all of the buildings, bridges, tunnels, dams, transmission towers, communication, power plant, expressway, industrial plant, everything. Everything that people use to do anything, to live, to work, to travel, they need us, right? That's how important our field is. And now we are moving to that level from basic learning to actual application to this level now, right? Where we will actually be doing some real level structures. So the overall role of the engineers, I've mentioned to you, this is borrowed from, the first one is borrowed from Dr. Ash's statement. And he says that we help to preserve the past and protect the present and build the future. So when you have the old buildings, you renovate them, you continue to use them, you design, and then you also build for the future, 100 years, next 100 years or more. So that means our job is not just temporary things. We are building something for a long period. What you build today will become past, and what you're building also will be used in the future. So it's a whole spectrum that we have to deal with. So when you design something, think about the lifespan of the things, right? This is so important, and we will talk about that. Second most important thing is reduce the risk of disaster for built environment. So not only we build something, but we also protect the people from hazards, for safety, for life, for property. So such an important role. I mean, honestly, if you think about it, we have one of the most important role to play. But people don't know. We also don't know. We don't get paid enough. We don't get recognition because we don't know our role. That's why last time I said we should be called the disaster risk reduction engineers. Then you will get paid a lot. You know, UN has no jobs for structural engineers, but they have jobs for people on disaster risk and sustainability. If you just change your title to one of that, you will start getting jobs there. Because structural engineering by itself doesn't convey what we do. It conveys how we do things, not what we do. So today we have to remember what is it that we do. And later, so I mentioned this one, designer, engineer, and artist. So now what we learned in the previous course was to be engineers. Now we won't learn to be designers. And then if you are really good, you will be one of the artists. There are very few structural artists, and I will show you a few of them, right? So now we move from engineers to designers in this course. So this is I captured from my Netflix movie. It's called Man in the Inside. And the hero in that series is a structural engineer professor, which is very rare. Normally they have lawyers and policemen, and structural engineers is very rare to be the main character, although he's a spy. But anyway, but he's a structural engineering professor. So this is what he's saying about in that program, and that's he's educating the people about structural engineering, and he's talking about the bridge.
Ultimately, is what distinguishes great engineering from merely useful engineering. Does the form match the function? Does the soul of the thing matter to those who use it? Is there a beating heart inside the utility? In this case, the answer clearly is yes. Thank you.
So what he's saying is that when you design something, it's not just about the function. You have to think much higher. Aesthetics is part of that. And does it really say something bigger than just designing a column? And then when you design something of that level, then people will appreciate. And if you don't, they will also criticize. So that means that if you want to be recognized by people, the definition of engineering should be something like that. And now we move from our first stage of materials to cross-sections, to members, to structures now. So first of all, why do people need tall buildings? Why this course is important? And does it have a future after graduation, right? That's the question. Should you study this course or not? That's what we are going to talk about. And why should we study this? So first of all, humans have always admired tall structures since the beginning because they're visible, everything has to be tall, big, much, much bigger than humans. It's only like 2 meters. And they try to make these things which are really, really big, right from the beginning. So that's one thing. Second thing, but that's not the reason that we need tall buildings. Tall buildings are sometimes symbolic, but right now we are talking about utility of the tall buildings, that they are actually essential, not an option anymore, not to show off, but because we need them. And we will talk about that first now. So you know that this subject, how important. So you can see here, huge structures have been made much bigger than human scale. Here, look at the column, and here. They don't need that. You need only this much height to go inside. Why do you make this huge structure? Nothing is happening in that one, right? Not being used. Only this part is being used. There's nothing in there. This is a big ceiling because people just want to show off the greatness and so on and so forth. So just make big things is our nature, to make things very big, much bigger than ourselves. So that has been going on forever in the history. And you can see most recently also everywhere you have these tall structures being, huge structures everywhere. Structural engineering is everywhere. You cannot drive, walk, go anywhere without seeing the structural engineering work, right? In this room, you have it's everywhere. So there's no place, except maybe in the desert, where you will not experience structural engineering. Okay. So why tall buildings? The first one is population growth. We know already that population growth is a huge problem and challenge still going on. Second one, people moving from villages to cities. That's not only population is growing, but people are moving to live together as close as possible. Symbol of development, important. Every city wants to be seen as a developed city. And what they do, they make buildings. And then environmental sustainability. Now, this is a question mark on both sides. Tall buildings, are they environmentally friendly or are they environmentally unfriendly? And there is an argument on both sides. But you will see that actually making a tall building is environmentally friendly in the long run. And we will show why that is the case. So that is the population living in urban areas. And let's see how that changed over time. So now you can see here that now all of the population is moving from rural to urban. Very few are rural areas left in the world. Everything has almost become, especially something in Africa here and there a little bit, but other than that, every country, the majority is moving to urban areas. So when you move to urban areas, the problem is land is limited, very expensive. You have to build vertical. You cannot go horizontal. There's no choice, right? So that means tall building is absolutely essential when you urbanize something. And here, look at the population. From 1 billion to 8 billion in 100 years. It took humanity 100,000 years to reach 1 billion. 100,000 years, roughly, to reach 1 billion. From 1 billion to 8 billion, 100 years. Can you imagine the change, the rate of change? So that means this is so huge that the tall building, other than that, there is no solution. So here you can see also timeline, how this urban population crossed the rural population over time. In the beginning, if you see that again, let's see that again. So you can see here that and all future population growth will be urban, no longer, which means it's just not going to be enough buildings where the population is growing. Of course, some part of the world population is not growing anymore. They're going negative, Europe, Japan, some other countries, but we are not there. We are in a region where that is not the case. Okay, so you can see here once again, by 2050, the urban population, the rural population will drop further and urban population will cross 10 billion, total 10 billion. So still 3 more billion people to go into the cities. And all of them need place to live, place to work, and place to entertain. All three things need tall buildings. So one person is using 3 tall buildings at any given time. One place to live, apartment, one place to work, office building, and one place to go to shopping and whatever they're doing in hospitals and services and all. So every person is responsible for at least three times the usage that they need. And 1/3 of the time, the place is empty because they're either here or there, cannot be at the same time in all 3 places, right? So we are building a lot, much more than we originally need. Now look at this one. If you take a house, 2-story house, and you have 50 meter by 50 meter space, you will make 10 small buildings for 10 families. If you take the same lot and make a 40-story building, then you will house 200 families. So that means there is a 20 times increase in the occupancy. So if your land is limited and you want to house many people because everybody wants to come into the city, then you have to make tall buildings to accommodate them. There is no way that you can accommodate them in the old style anymore, right? So that means the tall building is now a necessity, not a luxury. Okay, so that's the view from my previous apartment many years ago. But you can see here everywhere, and every year, the skyline changes in Bangkok. New buildings are coming around everywhere. Okay, so let's look at some statistics now, trends and statistics for tall buildings. Something will be interesting coming from this. First of all, of course, people always fascinated by the top 100 tall buildings. Everywhere you go, you get the same images, same things, tall buildings, super tall building, but that's very small percentage of the actual tall buildings that we are talking about. These are just outliers. These are not the ones that we are going to talk about because we'll look at their numbers and we'll look at their significance. They are just symbols, not solving the problem that we talked about. So these buildings that you see here do not solve any of those problems because there are very few in numbers and they're very expensive. No one can, Burj Khalifa, how many people can afford to live there? Not ordinary people, right? So it's for a very select few who can live there and for very select person. So although they draw all the attention, but they are not the one that we are worried about. You will probably not get to design Burj Khalifa in your lifetime because the companies who design them always design them unless you get a job there. But you will get to design a normal building that we will talk about. So this is currently, that is the list. So you can see here, people always look at them, and there's another one here, the Jeddah Tower, slightly above that, and this keeps changing. But this is a number that does not represent the reality, and we'll see why not. This is Dubai Creek, new latest project, latest tall building. Very interesting, and I will discuss this later. But right now, it's a very different tall building because it's combined the concept of a cable-stayed bridge with a building. So it's a cable-stayed building, first in the world of this kind. But look at what I want to show is not this one. You should look around what's happening there. So that's the reason these iconic buildings are made, to create around them a community of low-rise buildings which people will buy to look at this building, and they will just buy it for the view. So the people who made that building, they will not probably get any money. They will lose money on this one because it's so expensive, but they will make a lot of money from these buildings that they planned around them and sell the land. So they are always attractors for the total development, never the main thing. They make these iconic buildings, then sell the land around that at a high cost, so people want to live close to that building or look at that building. That's it. So that's where the money comes from around that. You can see here, there's a whole development plan in that way. Same for Burj Khalifa, same from everywhere. So it's never one building, but a whole setup that is done. But actually this building, this is the one that is being built. It's a little bit taller than that, but I heard that they made a law in Dubai that nobody will cross this one, so they had to bring the building down from the original one. I actually met with the designer of that building in Dubai when it was being launched, but now I believe that they have to reduce it below, according to some new regulation. Now this is the interesting part that you should watch. This is the time here, starting from 1930 to 2023, 24, and this is the number of tall buildings in different regions, in different colors. So this is blue is North America. This color is Asia, Middle East. Actually, they separate Asia and Middle East, although they're the same, but Middle East is separate. Then Europe, South America, Oceania, Australia, and then Africa. And look at the dropping number of buildings in North America. Number of tall buildings in North America have dropped significantly over time. In the beginning, up to 1980, 1990, all of the tall buildings were in USA. Nothing outside. Almost all there. And after that, almost all outside USA, not many in USA, right? And that's where we are in that region now. So look at that. So that's the trend. So this Asian region is the blue one, is the bigger one. And Middle East, if you combine Asia and Middle East, which is the same, you get 80-90% building here. Of course, major part is in China, but that's a different, we'll talk about that in a few minutes, right? So you can see now that population growth and tall building development are interrelated. Where the population has stabilized, urbanization has become 80-90%, tall buildings, no more new tall buildings will be made. But where urbanization is still happening, population is still growing, tall buildings numbers will increase. Okay, and this is where you are going to be working. Second one is by function. This is also interesting. Tall building, purpose of the tall building. In the beginning, almost all tall buildings were office buildings. People didn't want to live in a tall building. They can go, come back, and work, stay in their house, drive away, especially in US. Because in US, the tendency is a downtown and there is a suburban area. So people live in suburban and then they drive to downtown and go back. That's why when the main focus of tall building was in America, that was the model. But when the tall buildings moved outside of America, people start to live in the mixed use buildings. That means office and residential or mixed use. Their purpose is growing. So people don't make building for one purpose only. Office, residential, hospital, shopping mall, together. The concept of vertical city. So they don't want you to go around. They just stay in one building and do everything. So mixed use has now increased so much that is the main type of building now. Almost every new tall building is mixed use, 6-7 uses. So you can see here the trend is going like that. So all new buildings will be mostly mixed use type. Now let's look at the material. I showed this slide before also, and you can see here, when in North America, it was all steel. When the buildings moved to Asia, it's all concrete. And now steel almost disappeared, and now composite come in with that. So now you can see from here that the steel has gone almost down, and composite has become bigger. Concrete was, and then so we have concrete and composite taking most of the space in terms of the material of the building. Composite is mostly coming from China, and concrete is mostly coming from other countries. And you will see later how big the China numbers are. And you might be surprised by that, or maybe not. Okay. So this is another important observation. So we have seen that the type of building is changed, the location of building is changed, the material is changed, right? So moving forward, we should look at those trends. Then interesting observation is that the average height of the building has not changed. The tallest building keeps getting taller because people want to compete, but the average building that people use, that average height hasn't changed. It's still 200, around 150 to 200 meters. That's the sweet spot. Economical building that people can make economically, can live easily, can, you don't need advanced stuff there. So now you can see that over time, that trend hasn't changed. And this is what very important note for this course, that we should be targeting the buildings for this course where the numbers are the largest. The chance that you will be working on it is the one. We don't need to work on a super tall building because it's useless. We need to work and understand this range of buildings that most commonly being made and will be made. So look at that, 200-meter buildings, their number has grown a lot, and last 3 years, now they start to level off. That means this is the range that now we are above 200 meters will be less, below 200 meters will be more buildings in this range. But they expanded a lot in this 35 years from 1990 to this one. And then after that, now the numbers have become almost leveled off, and buildings in the lower range are now becoming more popular. Okay. So there's so much data there that you can look at, and then look at the trends, and then you can learn a lot from there what's really happening. So now completion by city. Which city has the most tall buildings? Shenzhen. So Shenzhen, and then Dubai, and then again China, and then India, and Kuala Lumpur, and so on. This is by city, but this is not a good number because we have to look at many things. Okay, but if you just look at by city, you will see that New York has gone down quite a bit. New York is somewhere here, last one. No longer the city with the most tall buildings. It used to be the only city with all the tall buildings. Now it's way down. This is the new ones in 2030. Not all. This is just the new buildings in 2023. So do not mistake for the total buildings. I'm talking about new buildings made in 2023 by city, not all. So if you look at all, the numbers are reverse. Okay? But this tells you where all the action is happening. Okay, this is the one that I want to especially focus on. The number of buildings in different range. Please watch carefully. This is the numbers for buildings between 150 to 300 meters. These are the buildings which were about 60 story, 60, 70, less than between 40 to 60, 70 stories. And those are the buildings above 300, like 100 stories or more, right? Or 90 story and more. And look at the numbers in hundreds and thousands. And this is just very few, 0, 1, 2, 3. That means almost those numbers are negligible. And look at the country also. So you will see that in our region, Malaysia is number 4 in terms of the total number of buildings, 295 buildings, tall buildings in Malaysia, and total. And then we have Indonesia, Thailand, and Philippines, all with 130, 120 buildings, right? A lot. And then we have India with 122 buildings. But these are where most of us in the ASEAN region, where the things are now happening or have happened, that most of the tall buildings are actually in these cities. Bangkok is one of them. Out of these Thailand, almost all of them are in Bangkok. But look at the range, this range. In Philippines, there is 0 building, 300 plus, but there are 128 buildings in first range. So that means we are looking at a range between 150 to 300 as the sweet spot where almost major, and this is the area that we will be focusing on. And if I show that numbers again different way, this is the interesting part. So if you look at that one, this gold part is China. Half of the buildings in the world now, on the top 12 countries, is China. And all the other are the rest. So that means one country is actually making more tall buildings than other 10 top buildings, top countries, between 100 to 300. 300 plus, again, China, but very few. But the thing is that you can see that here, this green color, UAE, is become higher. So UAE is making more super tall buildings than other countries. But because they are making it, they have small space, and they want to, for iconic reasons and all, so they're making more of these compared to other countries. But overall, China still leads. And this one is the total: China, USA, ASEAN, four countries, and then UAE. So if you look around the world, you will find that most tall buildings are in China, followed by USA, followed by ASEAN region. Here, 5 countries, followed by UAE, and then the rest. So once again, the numbers clearly show that where most of the tall buildings are being made. And so these are the numbers. But important thing for you to note is that all over, there are only 2009 very tall buildings compared to 6,000 normal tall buildings. 6,000, that's a lot of buildings, against only 200, a very small fraction. So we are focusing on this number rather than that number. But when you look at it another way, very different picture comes up. If you divide the number of buildings by population, you get a very different. Here you can see China is dominating everything, right? But if you take number of buildings per 10 million people, then you see that UAE is very high because very small population, but very large number of buildings. So per population, UAE is far more than any other country because numbers are very large, population is very small. So they are building, because it's a completely urban city. There are no villages. There are no rural population. 100% population in Dubai or UAE is urban. So that's why you have this number. So US and China per population almost the same. Then Malaysia, again, another very high. Australia, very little population, but a lot of building. Thailand and Philippines. And India has a few buildings, but their population is so large that you can't even see their number per population, 10 million, because the population is so large. So which means in India, the potential of new tall building is completely untapped because most countries have reached around this level, but India is over there. So they still have to make thousands and thousands to be visible in this list, right? So most countries will come back to around this level of about 30, 40, 50 in the end. So we still have a lot to go. Indonesia has a lot of tall buildings, but population is so large. So the total number is still. So we should look at this graph more than the other graphs for the potential and the lack of tall buildings for infrastructure. So this gives you the more clear picture of what's going to happen in future. Okay, let's look at Thailand a little bit more in detail. So Thailand, these are actually I'm missing 2 buildings here. I will add, this is until 2020. So the 2 more buildings have been added here on this side, but these are the current tall buildings that you see. You can see mostly only 2 or 3, about 300, and there are a lot of buildings in the 250, 200 to 250 range in Bangkok, quite a bit. How many of them have you seen? This building, because at the top of the building, there is a glass cantilever, and you can walk on the cantilever. If you are not afraid of heights, then you can look down and you can see the whole thing starting from the top of the building. Yeah, this used to be a tall building for a long time, built in 1997 by Oak Tower. And at the top here, this portion is a revolving restaurant. So if you haven't been there, it's very not expensive. Just go to a restaurant, sit, and then one round takes about 10 minutes. You can see the whole Bangkok. So that's one place to visit, this one. And then one place to visit here is a glass top here. And there are few, this is Lebua State Tower. Lebua, this is a restaurant here. And it's one of the most expensive restaurants in Bangkok. Okay, now the question is, how do you measure the height? This is one of the most controversial debate in the world. how do you measure the height of a building? You might think it's very simple, but complicated, but actually it's very complicated because people make the buildings with all kind of things, and somebody wants to include the top of the spire, some antenna, somebody wants to include the livable floor, so everybody wants to measure the building in which they are the tallest, right? So then somebody has to come back and make some rules. And those rules are made by what is called CTBUH, the Council of Tall Buildings and Urban Habitat. They are the one who are the most prominent organization in the world related to tall buildings. It was started by structural engineers, but now it is run by architects. As you can imagine, structural engineering is now no more there. They just took over everything. I used to attend their conference quite a lot, but now recently I found that it's mostly about developers, architecture, sustainability, elevators, facade. They don't talk about structural engineering anymore. Anyway, so this is where all the data is. So you can visit their website, and you need to know a lot about this organization for this course. Okay. So they define everything. So they say that the tall building doesn't have to be tall in height. It's a relative tallness that matters. For example, look at that. These two buildings are the same height, but here it looks tall. Here it doesn't look tall. Same height, right? Because of what is next to them. So it's also relative. And relative is important because I remember when I was starting my practice in Lahore, the 12-story building was the tallest building somebody wanted to make. And they wanted the most top-level structural engineer to do that because they thought it's the tallest building. We must have a structural engineer with a lot of experience and expertise in tall building. But when I moved to Bangkok, I found tall building is nothing. People design it in a sleep. Nobody cares about a 12-story building. 40-story above, they will think about some engineer who with some, otherwise 12-story building is like anybody can do it. So it's relative. In one city, 12-story building at that time was the tallest building, so it was very tall. But in another city, nobody cared about that. 30-story building, nobody cared, right? So that's the relative tallness. Second one is the tallness in terms of the proportion. So these two buildings are same height. This you will say tall, this you will not say tall. You will not think tall, right? But both of them are the same height. So height is not the criteria. It's the proportion also. So it's the relative location and it's the proportion also matter. And the next one is technology. So if a tall building has some special element for lateral loads, then it's a tall building. If lateral load is important and you have to manage the lateral load by a special technique, it's a tall building. So it's also about technology used. So three things: relative height, proportional height, and technology. These three things define when you say I'm designing a tall building. And then there are three categories that normally people use: tall, less than 300 meters that we talked about, most of the building, then super tall, 300 meters above, and then mega tall, 600 meters above. And there are only 3-4 buildings which are mega tall. And there are few buildings in this region, super tall. And then most of the buildings lie in the tall range, less than 300 meters. So how do they measure the height? I was saying, so you can measure the highest occupied floor, which is here, highest architectural component, which is here, and height of the top of the tip is here. So same building has 3 clear heights. So depending upon which level you compare, you get different ranking of the buildings, and people fight for that. Some buildings claim the highest hotel in the world, highest apartment in the world, highest communication tower in the world. So depending upon how they make it, they will compare their buildings. So Willis Tower in Chicago is very tall. If you do like that, this is Petronas, which comes here, but it is not considered taller than that. And this is the architectural height is here, and then occupied height is here. So you can see that the buildings, when they want to be in the top, they have to fight about which criteria they will follow. So it's not necessary the tall building itself is tall. Maybe the antenna is too tall. So this is something that is quite, so normally they report these 3 things now. So you can decide for yourself. Occupied floor, architectural floor, and tip. 3 heights are normally reported, and then different ranking comes up from there. Strictly speaking, it should be the architectural height, because that's where the structure ends. The rest is antenna, right? So normally for structural engineering, this is the height that we will be thinking about. So multi-use and single use. So this is if 85% of the height is occupied by the same purpose, it's a single use. So if it is 85% is apartment, it's an apartment building, single use. Or if 85% is office, it's an office building. But if it is mixed use, then that means anything which is more than 15% of the total, then it becomes mixed use, like hotel, apartment, these things are mixed together. There are buildings which have 6, 7 different types of uses. Most buildings have what we call a podium, where you have a shopping mall, and then you have the office building, and then you have the apartments, and then sometimes you also have a hotel in there, things like that. So hotel, apartments, office building, shopping center, maybe a hospital or something like that is now common in many buildings. And what that means for structural engineering is that you have different loadings coming up. For each type, the loads are different. Performance criteria is different. The grid is different. The layout is different. Parking is another one. So sometimes what happens is that the columns are coming down, and then suddenly there is a shopping center with a movie theater here. You cannot have the column in the center of the movie theater. So all the columns have to stop at that level and then start again. So you have this major structural discontinuity that you have to manage. Parking layout is different from the residential layout. So you cannot have columns through the car parking, obstructing the cars. So it's always a challenge fitting the car parking and the shopping center and the movie theaters and the bowling alleys and the apartments and the hotel in the same vertical grids. So another thing is difference between a tower and a building, because some towers are very tall, but they're not counted as buildings. So they say at least more than 50% should be occupied, then it's a building. If less than 50% is occupied, it's a tower. And doesn't compete with the building category, right? So there are many towers which are very tall, but they're not buildings, unless they have 50% or more area where people live. So these are all things that we need to understand when we talk about the design of buildings and tall buildings especially their height consideration. Now, another one, which is a very important consideration that you will see later, is the buildings which are connected together by bridges. This is becoming so common. And you saw that video after the earthquake, 2 buildings in Bangkok, connected by a bridge, and they're separate. So how they did not design that bridge properly, and then the buildings moved, the bridge was disconnected, right? So bridges connecting the buildings are also another challenge. And these are co-joint buildings and so on. So this is a building where the 2 towers start at this level. So they're co-joint, and then you have tower. And this is a building that connects at the top. This building is very different. 2 towers are coming, and then at the top, they connect to each other. Very different. And they're connected not just by a bridge, but by a building, just run through one tower continuously to that one. By the way, the designer of this building is also the designer of the Mahanakhon building, architect, Same architect designed this building and the Mahanakhon, that building in Bangkok, and also a very interesting building in Singapore. This is our course. Buildings between 150 to 300 meters is what we are going to study. The things that we will study will apply to buildings of this roughly range. Yes, of course, you can also apply some of those things to up to 400 meters, but not to that one. So mega tall buildings are definitely out. But tall to super tall is nearly the same rules, not much difference. So we will study this portion. This is where most of the buildings lie or will lie in the future also. So that's the focus of our course.